We have capacitor and a coil. So this resistance is the internal resistance of the coil. Maximum voltage amplitude is given, frequency is given. We need to find the current amplitude in the circuit, phase difference between current and external voltage, amplitudes of voltage across the capacitor and the coil. So when he says and the coil, we need to find the current amplitude across these 2 points. And I've added one more part on my own, that is, if voltage source is Vm cos omega t, find voltage across capacitor and coil at time t. So let's begin one by one. First is current amplitude. So we have the voltage amplitude. So current amplitude will be simply Vmax divided by total impedance of the circuit. So Imax is Vm by Z. Z is root of R square plus omega L minus 1 by omega C whole square. So we must be familiar with this. Second part, phase difference between current and external voltage. So let's solve this with phase diagram. So again, because it's a series circuit, we'll keep current along x-axis. So R will also be here, XL here and XC here. So this angle phi, so at this angle phi is where the voltage will lie. And tan phi will be XL minus XC upon R. So if I draw the voltages, it will be like this. So VR, VL and VC, and this will be final voltage, which is ahead of current by phi. Now all these are variables, so don't worry about that V should be above axis or below axis. So that's because all these are just variables. So in this diagram, what we are seeing is V leads current by phi, and phi is given by tan inverse of XL minus XC by R. XL is omega L, XC is 1 by omega C, and then we have R. So if we solve that, that comes to be a negative number. So tan inverse of that negative number gives phi to be minus 60 degree. So this implies our assumption was wrong. So VC is larger than VL. So that means the voltage will be down and current will lead. So the angle is minus 60. That means current will lead voltage by 60 degree. So that's the answer for second part. Third part, amplitude of voltage across capacitor and the coil. So what we do is simply we take the maximum voltage which is given. So we take the fraction of that in the reactance. So Vm into reactance of capacitor upon total impedance will give voltage amplitude across capacitor. And across coil, we will again take the maximum voltage Vm and then we'll multiply it by the reactance of the coil divide by total impedance. So that will give the voltage amplitude across coil. So let's see that. So VCM across capacitor, maximum voltage is maximum current into XC, and maximum current as discussed, so sorry, not discussed. So it is Vm by Z. So this comes to be Vm into XC by Z. So I was directly telling you can just take the fraction of the maximum voltage and just, so the fraction will be XC upon Z. But this is the, I guess this is the more reasonable way of arriving at this, where you can see the maximum voltage is maximum, because this is a constant XC. So reactance times maximum current will give maximum voltage. Now when we write Im as Vm by Z, so another way of writing is Vm into XC by Z. So total voltage into fraction of the reactance, that is XC by Z. So we do that. So XC will be 1 by omega C, Z will be this. So this is our maximum voltage across capacitor. Similarly, maximum voltage across coil, so that will be Vm into X coil upon Z. Now reactance of coil will be root of R square plus XL square, because XL, R and C are all three so XL and R are perpendicular to each other. So that's why X coil will be root of R square plus omega L square divided by total impedance, which will be this. Now D part is if voltage is Vm cos omega t, find voltage across capacitor and coil at time t. So here, this is our overall voltage, total voltage, and we know VC will be along XC because VC is I max into XC. So this is VC, this is the total voltage V, and this is our current. So we need to find what is VC, VC we know, what is voltage as a function of time. So the answer of that is VC max cos of omega t minus this phase, the phase by which it is behind. Actually, this should be just VC. Alright, so VC is VC max cos of omega t minus phi minus pi by 2. So voltage phase is omega t, and we can see VC is phi plus pi by 2 behind. So its phase will be omega t minus phi minus pi by 2. Value of phi we have already seen. So that is this. And VC max we have already calculated here. So this is our answer. Across coil. So again we'll take V, which is at angle phi. Now in coil we have both XL and R. So in our assumption, we have taken this phi we obtained by summing VR, VL and then minus VC. So if we take only VR and VL, that sum will give you V coil. And let's say that's at an angle theta. So you can see V of coil is theta minus phi ahead of V. So phase will be cos of omega t plus theta minus phi, and magnitude will of course be V coil maximum. Not magnitude, I mean amplitude of the V coil. So our V coil becomes V coil max into cos of omega t plus theta minus phi. Now phi we already know, and theta will be XL upon R. I mean tan inverse XL upon R. So theta is tan inverse XL upon R, and XL is omega L. So this is our answer. This is V coil as a function of time. This is voltage across capacitor as a function of time. This is maximum voltage across capacitor. This is maximum voltage across coil. This is just a variable phasor diagram. So this phi came to be negative, which means the actual V will be below it. Or in other words, in this circuit, capacitor dominates. That's why current will lead. And this was the maximum current in the circuit, that is simply Vm by Z. Alright.